At 05:47 a.m., Vladimir Putin just slammed the door on peace negotiators, convinced his $2.8 billion air defense network makes Russia untouchable. At this exact second in Ryazan, that arrogance is about to explode. 4 invisible Ukrainian drones have already bypassed those invincible radars and are diving toward Russia's largest oil refinery, a $2.8 billion energy fortress. Inside the S-400 battery command post near Ryazan, the air was cold, but the radar screen was blazing hot with confusion. A Russian operator, hyper-focused on his console, was tracking contacts that appeared to be nothing more than a flock of birds. But every fiber of his training screamed that this data was a lie. Birds do not fly in an unflinching formation. Birds do not move at this terrifying velocity. And birds certainly do not make a direct high-speed beeline toward Russia's premier oil processing facility. His equipment, the colossal 92N6E gravestone radar, was designed to track massive targets, fighter jets, at a range of 400 kilometers. Yet it was struggling violently to maintain a consistent lock on these incoming contacts. Why? Because the kamikaze drones had radar cross-sections no larger than a football. Then the targets made their move. At exactly 52 kilometers from the target, and only 27 kilometers from the S-400 battery itself, the lead drone performed an extraordinary maneuver. It climbed sharply to 800 meters. This was a brutal, cold-blooded tactical decision, a calculated sacrifice designed to force the entire Russian defense matrix into a fatal decision loop. The drone had deliberately announced its presence. The S-400 operator instantly calculated the terrifying mathematics. The massive 48N6DM interceptor missile required 27 seconds to reach the UJ-22. But at their current speed and trajectory, the incoming drone swarm would breach the S-400's lethal 2-kilometer minimum range dead zone in just 41 seconds. This left the battery commander an agonizingly slim 14 seconds to decide the fate of Russia's energy spine. Was this a genuine catastrophic threat, or an elaborate decoy designed only to waste Russia's precious $1.5 million interceptors and distract them from a bigger threat looming elsewhere? 10 seconds now. The closure rate was undeniable. These were not electronic phantoms, and they were certainly not natural life. 7 seconds. Follow the manual or follow the instinct. 5 seconds. If he hesitated and these were not decoys, the Ryazan refinery would burn. 3 seconds. The immediate tactical future of Russia's short-term energy supply had compressed itself into a brutal split-second decision. With a desperate, swift click, the commander committed. 2 interceptors roared instantly from their vertical launch tubes. Their solid rocket motors ignited, accelerating the 1,800-kilogram missiles to a staggering Mach 6 in a flash. The exhaust plumes painted bright orange lines against the dark night sky, as $3 million worth of Russia's most advanced engineering screamed toward 4 Ukrainian drones that individually cost less than a luxury car. The Ukrainian counter-program was executed faster than the commander could blink. Detecting the S-400 launch signature, the UJ-22s executed their first pre-planned evasive maneuver. They instantly dove back down to an altitude of 150 meters. This single sharp descent made them instantly vanish below the radar horizon. They were lost like stones dropped into the blackness of an electronic well swallowed by the dense ground clutter. This generated Russia's first catastrophic technical problem: semi-active radar. S-400 missiles are not fire and forget. They require continuous target illumination. The ground station must continuously paint the target with radar energy. Without that lock, the Mach 6 interceptors were flying blind, relying only on outdated inertial guidance and the last known, rapidly changing target coordinates. While millions of dollars worth of advanced Russian engineering played hide-and-seek with themselves high in the night sky, the UJ-22s closed in on the refinery's final desperate line of defense. That line consisted of 2 Pantsir S-1 batteries. These systems were designed for close proximity defense, the absolute last-ditch effort. They were suddenly confronted with 4 low-altitude targets approaching at maximum speed, leaving them virtually no time to acquire, calculate, or engage. The Pantsir's own radar system, the RS-21E, was optimized for much larger threats like cruise missiles and helicopters. As the silky carbon fiber drones navigated the dense ground clutter and the intense thermal interference emanating from the refinery's own massive processing towers, the signal return was barely distinguishable from background noise. Ukraine's radar games had just created Russia's second fatal technical problem. The Pantsirs were left with a devastatingly short 12 seconds to acquire a stable lock and unleash their 30mm cannons before disaster struck. The operators hunted desperately, seeing only intermittent contacts flickering in and out of their displays like malevolent ghosts. Time was evaporating as they fought to swivel their heavy twin 2 A38M cannons toward the immediate threat. But the hydraulic traverse system requires precious seconds to rotate 180 degrees. Seconds they absolutely did not possess. 4 seconds left. The fire control computer struggled frantically. It needed to generate a stable tracking solution on targets that appeared and disappeared faster than the system could physically lock on. As the Pantsir swiveled and stuttered uselessly, the lead drone had already identified its primary target. It was using sophisticated electro-optical sensors, a targeting system designed specifically to distinguish between different types of industrial infrastructure. The target was the 120-foot-tall main processing tower housing the catalytic cracking units that convert crude oil into vital war products. The EO sensors had identified the optimal impact point, the single fragile point of failure where the main feed line entered the tower at its base, the point that would begin the irreversible domino effect of destruction for the entire Western processing complex. Suddenly, a massive, blinding flash high above momentarily paralyzed the Pantsir operators. The S-400's interceptor missiles, flying blind and guided only by their last coordinates, broke through the night sky like lightning. Both missiles detonated. Their enormous 180-kilo fragmentation warhead sent 24,000 hardened steel shards screaming through empty air at 2,100 meters per second. The blast pattern was technically perfect, but the targets had already disappeared. The UJ-22s had perfectly navigated the lethal razor's edge, the narrow zone between the S-400's radar horizon above and the Pantsirs stationed below deck. The S-400 commander, watching the data feed, could only stare in horror as millions of dollars in Russia's most advanced air defense munitions were wasted on empty air. The enemy, the bogies, were bearing down fiercely toward the liquid gold. These UJ-22 airbornes are not mere flying bombs, they represent the terrifying evolution of Ukrainian drone warfare. These machines can actually assess threat data in real time, adjusting their flight course every 50 milliseconds. Because each drone is pre-programmed with the radar frequencies and engagement envelopes of every known Russian air defense system, they can execute pre-planned evasive maneuvers the instant they detect a threat. This is an autonomous weapon system that can literally think, adapt, and survive in the most hostile electronic environments on Earth. The defense interceptors had exploded uselessly above. The moment of brutal decision had arrived for the Pantsir operators. The mathematics of survival were cruel and unforgiving. Only seconds remained before total impact, and each Pantsir could engage only one target at a time with its twin 30mm cannons. The Western Pantsir operator made his choice first. He focused all available firepower on the closest drone, hoping desperately to stop at least one before the facility was breached. His cannons opened fire, the lava-hot barrels instantly spitting 30mm high-explosive cartridges at a staggering rate of 2,500 rounds per minute. The muzzle flashes strobed across the refinery like a frenzied laser show, filling the air with dozens of zirconium core projectiles designed to shred full-sized aircraft. The fire control computer scrambled violently to find the proper lead. The drone's current speed and crossing angle demanded the system aim 31 meters ahead of its perceived target position. But again, the UJ-22 was programmed for this exact scenario by Ukrainian engineers who had meticulously studied 2 years of drone air defense engagements. As they closed range, the UJ-22s unleashed their most devastating electronic trick: dynamic altitude variation. This involved generating random, unpredictable changes between 40 and 80 meters in altitude, using barometric pressure sensors accurate to within 1 meter. The pattern was generated by true random noise within the drone's processor, making it mathematically impossible to forecast. The Pantsir's fire control processor operates on predictive targeting algorithms. It calculates where the target will be in the 0.8 seconds it takes for the 30mm rounds to travel to the intercept point. These algorithms work perfectly against aircraft that maintain predictable flight paths, but random altitude changes turn prediction into mere probability theory. The hit probability instantly plummeted from a secure 83% against a steady target to a pathetic 31% against the bobbing, weaving kamikaze drone. The operator watched his tracer rounds pass harmlessly above and below the enemy. His ammunition counter showed 420 rounds remaining, just 6 seconds of continuous fire. 6 seconds to stop 4 drones carrying enough explosives to cripple Russia's energy infrastructure for months. The northern Pantsir was grappling with the identical unsolvable problem: not enough processing power to counter Ukraine's cutting-edge drone capabilities. There was no luck left. At 05:52 hours, the lead drone's proximity sensors finally achieved a hard lock on the main processing tower, now only 50 meters ahead. It entered its terminal descent, its 20-kilogram payload ready to inflict unimaginable pain. This warhead was not a simple explosive. It used a shaped charge specifically engineered to penetrate industrial infrastructure. The copper liner focused the explosive force into a jet of superheated metal traveling at an astonishing 8,000 meters per second. Fast enough to punch through reinforced concrete, thick steel plating, and the high-pressure vessels containing thousands of tons of volatile petroleum products. Ukrainian engineers had done their homework, studying the architectural plans of these Soviet-era refineries and identifying precise structural weak points. They knew exactly where a small explosion could trigger catastrophic secondary effects. The special warhead detonated precisely where the flight computer had calculated, at the critical junction between the main processing tower and the fuel distribution manifold. This was the single point where 40,000 liters per hour of refined petroleum flowed through a network of high-pressure pipes. The resulting explosion created a multi-meter breach in the primary containment system, and 380-degree petroleum instantly began spraying across the facility under 40 atmospheres of pressure. But this was only the primer charge in a meticulously orchestrated symphony of destruction. Drone 2 struck seconds later. Its warhead penetrated the main pumping station, the heart that maintained pressure throughout the massive distribution network. The explosion severed 3 high-pressure fuel lines simultaneously, each one spraying thousands of liters per minute of gasoline, diesel, and aviation fuel across a staggering 200-meter radius. The pumps designed to move petroleum products at industrial scale were now unwittingly creating the perfect conditions for a massive, terrifying fuel-air explosion. Drone 3 arrived exactly as programmed. It struck the electrical substation that powered the facility's fire suppression systems. The resulting explosion sent 50,000 volts arcing through the morning air. Transformers detonated in blinding showers of sparks and burning oil. Emergency lighting throughout the vast complex instantly failed. The critical fire suppression pumps went silent. The deluge systems, the only systems that could have contained the spreading petroleum fires, were now permanently offline, their control systems fried by the electromagnetic pulse from the electrical explosion. Drone 4 completed the tactical masterpiece. It penetrated deep into the storage tank farm, where 3 massive containers held 50,000 tons of refined petroleum products. The shaped charge punched through the reinforced steel walls, maintaining coherence just long enough to breach multiple targets via a horrifying domino effect. Petroleum began flowing rapidly from the ruptured tanks at a rate of 10,000 liters per minute, mixing with the high-pressure spray from the severed lines to create a vast, volatile lake of combustible liquid covering 40 hectares of industrial infrastructure. Shortly after the first impact, literal tons of petroleum had mixed perfectly with oxygen, reaching the ideal stoichiometric ratio for catastrophic combustion. The initial fires from the electrical substation explosion reached the fuel spray from the severed lines. The temperature spiked violently from 20 degrees Celsius to a hellish 800 degrees as the deluge of petroleum ignited with unstoppable, crushing force. The initial thermal shockwave shattered Moscow's long-held confidence that critical infrastructure deep within the homeland was still safe. Then, the real inferno began. Storage tanks began cooking off in rapid sequence as the fire spread uncontrollably through the underground pipeline network connecting every part of the facility. Each explosion fed the next, creating a self-sustaining chain reaction that ruthlessly consumed the entire western section of the refinery. Tank 7 exploded at 05:53 hours, sending a colossal fireball 200 meters into the sky. Tank 12 followed moments later. By 05:54, temperatures inside the complex had reached a destructive 1200 degrees Celsius, hot enough to melt the very infrastructure that held the facility together. Moscow's fuel supply had just been cut dramatically by just several minutes of breathtaking precision warfare. The strategic ramifications were instantaneous and devastating. Within 6 hours of the coordinated drone attack, Russia was forced to initiate the largest air defense redeployment seen since the opening days of the war. S-400 batteries, the very systems that failed to stop the attack, were desperately rushed from frontline positions near Ukraine to protect critical energy infrastructure deep inside Russia. Pantsir systems were pulled from crucial ground force support missions to bolster guards at refineries and power plants across the country. Every single air defense system recalled from the Ukraine front to protect the homeland created dangerous, exploitable gaps in battlefield air defense, gaps that Ukrainian forces were guaranteed to exploit within days. The economic impact was equally immediate and brutal. Oil futures saw a dramatic 12% change in the very first hour of trading, as global markets fully realized that Russia's critical energy infrastructure was vulnerable to precision strikes. The next time Russia claims their air defenses are impenetrable, remember the burning refinery at Ryazan and the brilliant Ukrainian engineers who turned a handful of autonomous thinking drones into a strategic arsenal that changed the course of a war. Stay prepared, stay informed, and subscribe for more exclusive insight into the conflicts that are defining our future.